Hello everyone, and welcome to another Jura video where we're making a language in Java. And since last time, I've tidied things up a little bit. I've made the lexer follow the same pattern as the other steps, where you just hand it a list of something, you call a method and you get a list back. And I have made it so that we can now load files from the resources. And I say I've made it do that, it's very simple. So now we have the ability to write a separate file, and we can put in, different statements in here, and if we compile, it breaks because I forgot a semicolon. See? It knows that there should be a semicolon there, and yet it doesn't put it in for me. Maybe we should fix that. There we go. So we compiled that, and if we run it, true, 5 prints 5, 10 prints that, and then, let's see, 5 minus 2 is 3, 3 times 8 is 24, so that's that. So, cool. But, like, this isn't a programming language. Like, come on. So I want to just, like, flesh it out a little bit today, and hopefully by the end of today we'll have blocks, we'll have proper method calls. Not like proper methods or like function calls, but rather than just printing a value, I want something kind of like this. So I can be more explicit about when I want to print something. Because then this just looks really weird. Yeah, that. So I also want to have blocks, so I can do something like this, and group statements. And fuck it. Why don't we have variables today? Why not? Start building up actually having a programming language. I think variables will be a bit of a stretch goal at the end, because that's obviously maybe a topic all on its own. But for now, let's try and get this to compile. Because currently it says, what the hell is that? So this is really easy actually. Let's go to our lexer. Let's go to our token kinds. So we have open angle, open paren. So now we want open curly, close curly. Go to our lexer, and it's very easy to just add these tokens. Like that. And then when we parse, well, we want a new kind of statement. We want a block statement, which is a type of statement, which has a span. It has to be permitted by the sealed class, and then it needs to be final. This has an open curly and a close curly, and then inside it has a list of statements, like so. And its span goes from the open curly to the closed curly, and we want to be able to get the statements. Boom. So how do we parse this? Well, when we parse a statement, if we encounter an open curly, we just say, okay, well, let's expect an open curly, and then we expect a closed curly at some point. Not that, we yield a new block statement with the open curly, some list of statements, and a closed curly. So we need to parse a list of statements. Well, how do we parse a list of statements? Like this. So we just say list of, I hate that there's something called state in my path somewhere that's just messing that up. Statements, new array list, quickly let's get rid of that null, and then we just say while the cursor is less than the token size, just in case somebody forgets the curly at the end, while it's less than token size and tokens get cursor kind does not equal close curly. Statements, add parse statement. Like that. And then we expect the curly, so if we break out of this loop because the cursor went over the end because somebody did this, it will say, oh, I expected a close curly, but I got nothing. And then if somebody does that, then it will behave just fine. So that gives us a block statement. Easy. Easy, easy. We also need to have a typed block statement, which extends typed statement. Add that to the permits, make it final. And then type statements don't actually need, they don't have any behavior. They don't have anything that they need to extend. Interesting. Which means we need to have a private final list of typed statements, add it to there, and make a getter. So with the type checker, we're going to have an error because we have a new type of statement. So if we have a block statement, all we do is just make a list of typed statements, and then for, we could be fancy about this. We could just say block statement, get statements stream, map this type check to list. And we get our typed statements. And we can just yield a new typed block statement with our typed statements. How about that? Easy, easy. And then when we emit, in our emitter, we have a new error because we don't handle typed block statements. But again, that is very easy. We just block statement, get statements for each this. We just emit mv statement. Do that. Maybe that's a bit cute. It's a bit fancy. But oh well. So if we do that, this now compiles. So I could do 5555, compile that, and if true, we print 5 4 times. If we false, we print nothing. Blocks. And blocks can just go anywhere, right? Same as in Java. You can just take a particular part and you scope it. We'll get to scopes. And yeah, that then means that tokens is now defined in this scope, so it can't access it, So we have blocks. So if I go back to here and do true, this should just result in the exact same thing. Yeah. And if I look at the decompilation, you see we have just 4 consecutive print functions or print calls. The actual scopes. Oh, it doesn't actually auto format the Jura. Yeah, I added syntax highlighting for Jura in my IntelliJ. All it does is just highlight if true and false, and then it just handles stuff like pairing braces, comments, which don't actually do anything yet. That would be a compiler error. Yeah. Oh, and also we don't actually need the parentheses because this language is better than Java. See? Don't need them. Same way we technically don't even need semicolons, right? If I go to my parser and I do parse expression statement, I don't technically need the semicolon. It works fine without the semicolon. It's just useful because if you have multiple expressions on the same line, that's kind of weird. But it's still 5 expressions. And currently in Jura, if there's just an expression statement on its own, we print it. That won't always be the case. But yeah. For now, I think I want to keep the semicolon because it can be handy for when you're... because, like, depending on how we do certain initializers, if it uses the curly brace syntax, it might trick it into thinking that it's, like... if you're trying to parse this, it's going to parse this whole thing as an expression if it thinks that this is how you initialize, like, structs, for example. Well, to be fair, that's kind of why you would have the parentheses. But we aren't there yet, so let's not worry ourselves about it. So we have blocks. Now that we have blocks, let's add else, which is also incredibly simple. Because the first thing we need to do is add the else keyword. So we have the if keyword somewhere. There it is. If we add the else keyword, and we go to our lexer, go to parse identifier or keyword, if we see else, that is the else keyword. Boom, boom, boom. So, this is where we start to see this get more complicated. Because now we need to say, let's add something like private token kind peak. And let's add a specific end of file key token kind. And let's say if cursor is greater than or equal to the token size, we return token kind EOF, just so that we have a value to return when we peak. We could return null, I suppose, but I hate null. Returning a null is just asking for trouble, and my plan is that Jura is not going to have a null keyword. I'm going to see how far I can get without adding null into the like top level syntax of Jura. Yeah. Otherwise, we just return tokens get cursor kind. There we go. So, where were we? We were here, in the if keyword. Apparently I've left my Steam on again. One moment. Okay, so we've parsed this, so we say if peak equals. We don't need to do that because it's an enum. We can just say token kind else keyword. Then we say token else keyword equals expect next token kind else keyword. And then we just parse an else body. How do we want to handle this? I guess maybe we just have else body here, and here we have null. I know I just said that I hate null, so maybe we could make this an optional, but I don't know. Let's have two constructors. And we don't even need the else keyword because we have no reason to ever return it, I can see. Because like when we do the span, we're going to do the span to the else body. In fact, that's a great point. If else body is not null, return span from the if keyword all the way to the else body. There we go. And then we want a get else body. There we go. So we don't even need to... how do we want to format this? Yeah, that's fine. Yeah. And then what's cool is because we're recursively calling parse statement and an if is a statement, we automatically get this. Right? Because this is its own independent statement. You could have that on its own. It doesn't matter that it's here. You know? So we get else if as sort of like an emergent property from this. So let's do something like this. So we want to see 6. So we parse, we get this. So now in our typed if statement, we now may have an else body. Equals false equals null. And then this one has a typed statement else body. You know, to be honest, this should probably be something like condition body null. Yeah, I prefer that. Then you're not repeating yourself so much. And we want to be able to get the else body. So let's do the same to if statement. We just say if keyword condition body null. Much better. Now we only have like one constructor that's actually doing anything. The others just kind of like if I ever wanted to change this for whatever reason, like maybe add validation that these are all not null except for this one, obviously, then this constructor gets it for free. So now we need to type check this properly. So we get the body and we say if statement get else body is not null. Then we just say else body equals type check if statement get else body. And then we just yield a new typed if statement with the condition, the body, and the else body. Easy. And then in the emitter, when we emit this, yes, this is horrendous. We emit this if it is. Yeah, this gets more interesting. Okay, so what we're doing is we're pushing the constant 0. We emit the condition. Now, there are no booleans in Java bytecode. There are only integers, or rather, the way you represent a boolean is with an integer. There are other types. But for a boolean, it's just actually an integer, or like a byte, I think. Or it might just be an integer. Yeah, because we're pushing a constant integer, not a constant byte. Although this probably is just a byte. Anyway, all that's to say is we push a 0, we emit that. So on the stack we have 0 and then our condition, which eventually will evaluate to either, you know, a 1 or a 0. And then we create a label. We say if this is greater than, or rather if this is greater than this, so if we ended up with 0 or a negative number, jump to false, which is the label after the body. So we want to say if statement get else body is not null, we just want to emit that. I think so. But if it is true, we don't want to do the else body. So we need to have another label and just jump to it after we do this. So we just say emit mv, not like that. We want to do mv visit. Do we have a jump instruction? Yes. Jump instruction. What opcodes does that take? If this mv. Okay, you're doing some weird stuff there. So what jumps do we have? Jump to subroutine. I just want to jump. What am I doing here? Yeah, so that's just, I want an unconditional jump. Do I have a visit go to? Or like just go to? Can I just do jump instruction go to if true? Does that work? And then I visit the label after here. So we're always jumping to the end. In the case there's no else body, doesn't matter. If there is an else body, we'll omit that between the if false label. So if the condition is false, we jump over the true body. If there's an else body, we omit it. And if we're here, we'll run the else body, and then there's if true. If it's true, we don't jump to that. We run the if body, or the true body. We go to if true. There. So instead of if true, let's just call this end. Go to end and visit label end. That makes more sense. Does that compile? Cannot invoke get kind because token is null. Interesting. What were we parsing? We were just parsing the whole thing. So, okay, it's unhappy about something. Let's simplify that and just do this. Still unhappy. Cannot invoke get kind because token is null. So we do that. While cursor is less than token size, parse the statement. Come into parse statement. If it's an if, let's step through. So we come into here. We get the if keyword. We get the condition. The condition is just the false keyword. The body, let's see, is a block statement with a single statement, which is an expression statement, which is an int literal, which is 5. Great. That is this part. So now we peek. And it is an else keyword. So we expect there to be an else keyword. Cool. And then we parse a statement. So we recursively come into here. Cursor is less than the token size. We get the token at the cursor, which is an open curly. So we come in. We expect there to be an open curly, and we get it. Good. While that, good. We parse a statement. We come inside parse statement again. We get the token. The token is int literal 6. So that means we come into the default, parse a binary expression. The expression is int literal 6. We expect a semicolon. We get it. We yield a new expression statement. Cool. So we, in our block, we yielded an expression statement. It's now a closed curly. Expect next is close curly. We got a close curly. All good. Yield a block statement. So the else body is a block statement with an open and close. With the statement is an expression statement with an int literal of 6, which is correct. Okay, so we yield that if statement, and we've added that. And yet we go in for more statements. Why do we go in for more statements? So our tokens, our last token is that close curly. Do I not consume? I do consume the close curly. Well, the cursor is less than the token size. Yeah. Huh. So if I jump back to here, my cursor is only 11, but I have 12 tokens. So if I do tokens get cursor null, how have I ended up with null? Yeah, not showing null elements. How about you do? Because otherwise, you know, I'm missing information. Great. That's really clever of you to hide things that are going to cause error. I fucking hate null. How do we end up with null tokens? If I go back here. Not there, sorry. Alexa. Do I ever return null? I do. The cursor... Okay. Cool. That's on me for returning null. See? This is why I don't like null. Because you get stupid problems like that. Okay. So we have if false 5, else 6. It prints 6. Let's go back to our if else chain. So this should print 6. It compiles. Print 6. If I change that to false, print 7. So we now have if else chains. Very cool. What should we do next? So we actually have else. Let's do variables. Because I think it would be nice if we could say, I'm going to use Java syntax for now, but that we can have a think about what the syntax is going to be. So if we say int x equals 10, and we say, God, I'd hate that this is like not that, you know, stuff like this. So we can declare a variable and then reference it later. That then gives us, you know, more power in the language. But I'm thinking, I don't like the type on the left. I think the in vogue thing now is to do shit like this, and then because this is implied, you can just do that. Something like that, because you'll always know what this is. I'm gonna have a think about how I want these to look before I actually go and implement them. What should we do? I think what actually we should do is we should start lowering before we start adding more complicated structures into the language. Like, I think what we should do, okay, change of plan. We're going to implement lowering. We're going to lower the if statement down to jumps. And then we're going to implement while. And we're going to implement while in the lowerer. But while isn't really useful until we have variables, because then you can say like x is 0, and you can say while x is less than 10, x, which will print x currently, and then you can just say x equals x plus 1. Otherwise there's no way to really break out of a while loop, because all the booleans we have right now is stuff like this, which we'll never be able to change because we don't have variables, or stuff like this, which means it's either an infinite loop or it will never go. Okay, I think that is the way forward. We're going to do lowering, we're going to do variables, and then we're going to do while. Okay, all good? Let's do lowering. Okay, so I think we're going to start by making a new package for this, because if we go back to here, we kind of have a package for each of these stages, and now we're adding lowering. Lowering. That's a fun thing to say. Lowering. Where we're going to have our lowerer. Also fun to say. And this is going to have lowered statements. Lowered statement. Yeah. So we're going to pull the same trick again. This is going to be abstract sealed. Is that it? I can never remember this syntax. Statement. Abstract sealed. Yep. Lowered statement. But we're not going to have lowered expressions because expressions are already as low as we can go. I guess for now. And so what the lowerer is going to do is have a list of typed statements. And it's going to have a public list of lowered statement. Kind of like this. And it's just the same sort of deal. We just make a list of lowered statements. Lowered statements equals new array list for statement in statements. Okay, this is going to be interesting. So we're going to have a public list lowered statement, lower typed statement. So one typed statement can result in multiple lowered statements. So we want to do add all lower statement like that, and then just return lowered statements. So we want to switch on the statement. So what statements do we have? We have three kinds of statements. We have a block statement, which is probably the easiest one to do first. So what this is going to have is a list of lowered statements, and then for let's just say in block statement get statements, lowered statements, add all, lower stumpt, yield, no, return lowered statements. Let's do it like this, so it forces me to implement them all. Cool. Typed expression statement. So this one's also very easy. We should make a lowered expression statement. I don't love that. Everything being duplicated so many times. And then make this final. So this is basically the exact same as an expression statement. It's just in our new type hierarchy. Let's add that to the dictionary because we're going to be saying that a lot. And this just has a typed expression. Like that. Yeah, so that's just going to be a new lowered expression statement, get expression. But it's a list of like that. So the if is the tricky one. So if we think about what we have with an if, in fact, let's ignore the case where we have an else body, because that's just going to make things really complicated. So we have just this. So we want to go from this, which has been absolutely mangled, that. We want to go from this, in fact. Christ. Like that. I want to go from this. I want to go from that to pushing the condition. I cannot type this morning. What is happening? Condition. So we want to push false. And then we want to push, like, what was it? If ek or whatever. And then we want to push the body. And then we want to push the label. Something like that. I can't remember the specifics. But from that, I know we want to have a label statement. And what does this have? It's probably going to have an identifier. But we'll get to that in a second. So the first thing we probably want to do is make a list of lowered statements. And we want to add lower typed if statement get condition. Yes, as part of lowering, we might also want to do some rewriting. So say this condition was like something and false. We could probably statically look at that and we could rewrite it so that it is always false, and so we just eliminate this code. That would be something we do here, but I don't think we want to just yet. So we want to add new lowered expression statement, like so. So we have the condition. Then we want to add a jump. So we want to have a we want a label class, I think. And that's what a label statement has? Something like that. And then this will have an identifier, I think. You can shut up for now. Actually, we don't want you to return null. We already have the thing we want to return. I'm just not finished with it yet. So we have that, and we want to have a jump statement. Yeah. And because we're targeting Java bytecode specifically, we know what kinds of jump ops we want. So what do we have? Yeah. So we have if ek, if greater than, if I compare not equals, stuff like that. So if I just have jump op if eq for now. I'm kind of making this up as I go along, so if this doesn't work, I'm sorry, but so this is going to have private final jump op. Let's say jump op. Private final label. Like so. And then we just have getters. Okay. So we have the condition, and then we want to say new jump statement. So let's make a label, a new label, and this is going to be if false. So we say if ec. How does if ec work? If value is 0. Yeah. So jump op if ec. Let's make it easy for ourselves. If 0. Rather than if ec, because if ec to what? If 0, we jump to if false. Okay? That is our jump. So we have lowered the condition. We say if it is 0, we jump to this label. And in fact, let's just call this end for now. If it's false, we jump to the end. Then we say lowered statements, add all, lower the if statement's body. And let's just call this if statement, not typed if statement. Okay, so if it's false, we jump over the body. But we need to jump to this label. So we need a label statement. Add new label statement, end. Okay? Does that make sense, what I've done there? I've kind of broken it down into a more flat. If anything, yeah, this is like flattening the structure of it into just like, you know, because the bytecode doesn't have structure, it's just a sequence of bytes. And so that's kind of what this has done. Okay. So let's completely break our bytecode emitter again. So we want to say the lower equals new lower with our typed statements. Why are you angry? Cool. And then we want to say a list of lowered statement. Lowered statements equals lower. And we want to hand those to our bytecode emitter. So we've broken our bytecode emitter again. So let's say we want to emit lowered statements. For statement and statement, we want to emit a lowered statement. And this is very easy. So first of all, we no longer have block statements. Be gone. We no longer have if statements. Be gone. We do have lowered expression statements, which we handle exactly the same way. But now we have a whole load of new statements. And by a whole load, I mean 2. So, how do we do this? So we now have state across different branches. So for the label statement, we want to kind of get the label, and so not conflict with the bytecode one. I'm going to call this a Jura label. Yeah. Actually, I don't want that to be called Jura label. I just want that one to be called label. There we go. And then yeah. So we have our label. So if we visit a label statement, we just want to env visit label, and we want to get. Okay. So we want a private final map of how do we want to do this? For now, let's just do string to label and say labels. And labels is a new hash map. So let's say this has private final string ID, like so. And then in here, oh, I don't have random string utils. Do I have UUID? I do! Random UUID. Why not? Okay. So we have that, and then we say labels get label get ID. And this is going to be bytecode label, and then we visit it. If the bytecode label is null, throw new illegal state exception. Could not find associated label with something like that. This should never happen though, because in our jump statement we have a jump op and we have a label. And we just want to say labels put label key or get ID a new label. And we want to say switch jump op mv visit jump instruction. Well, first of all, we need to actually have a case. If 0, visit the jump instruction if ec, and we jump to this label. We'll call this bytecode label. And then just because, let's add unhandled jump op this one. Does that make sense? If we encounter a jump statement, we figure out what kind of jump op it is, we get its label. Can we do have a compute? Yeah, compute if absent. Or compute if... Yeah, we could probably do something more clever, but for now, the jump statement is the first time we find the label. And then the label statement, we imply that, or we assume that the label has already been created. This might not be true when we add else, but let's see what happens when we run this. Yeah, we get an error. Okay. Ooh. Interesting. It doesn't like that. I think because we have, yeah, compute. I'll change that to compute maxes. I get rid of that. We might have to start learning about stack frames. What did that actually emit? Yeah, it emitted nonsense. And if I try and run it, what's it complaining about? Exceeded max stack size. Okay. If I put that back. Yeah. Tempted to pop an empty stack. Oh, I know why. I know why. Okay. Let me put it back to computing the frames, because I don't want to do that. Because we're comparing equal to 0. Oh, hang on. No, because if ec only consumes one value. If the value is 0, branch to branch offset. And we've lowered it to the expression, is it 0, jump to the end, and then the body. I think we should do a little bit of debugging. What are our lowered statements? We push false. We jump if 0 to this label. 10 label. Yeah. That should be fine. But it's complaining because it's not a very good error. Negative array size exception. I think I need to learn about stack frames. Okay. I'm going to take a bit of a break. I'm going to look up what this error is trying to tell me, and I'm going to come back and I'm going to implement this properly. Okay, I figured it out. And it's because now that whenever we emit a lowered expression statement, we're wrapping it in the print. But the problem is, before, when we emitted the condition of an if, we weren't coming into this. You know, we were emitting it as part of a binary expression or something like that. And what's happening is we're emitting the condition, but then we're immediately, and that puts it on the stack, and then we're immediately popping it off of the stack because we're printing it. And so this where is it gone? Where has it gone? Emit statement, expression statement, jump statement. Yeah, when we emit this if ec, we're trying to pop a value off of the stack to check if it's equal to 0 or not, but we've already popped it. So if I get rid of this printing and then run it, well, first of all, it's been a while, so Gradle has to cold start again. Love Gradle. So this is what we're compiling. Didn't even compile. What happened? 0 out of bounds. Because now we are leaving this on the stack, so we need to get rid of that. And now it works. But that's not very useful, because now we just have this. And I would like to be able to print that 10. So I think we're going to have to do something like this. And I think we're just going to cheat for now. So I think running this as is going to complain that we don't know how to parse an identifier. There we go. Unexpected token identifier. So where is this? This is in primary expression. So, if we're parsing an identifier, what could it be? Well, it could either be a variable, it could be a function, it could be some sort of class name, like a type name. But for now, doesn't really matter. The only thing it can really be is a method, and that only method is print. So, how do we want to parse this? Well, first of all, we need to add these kind of parentheses. Oh no, we already have these parentheses. Oh, it's been a couple hours since I last looked at this language. I need to remember what I'm doing. So, we have an identifier. Let's get that identifier. First of all. And then, for now, let's just expect an open parenthesis. Let's get an expression. And let's get the close paren. So we're going to very, very hard code print for now. That's complaining because we aren't returning anything. So let's yield. Oh, no, it's not. It's because I did token kind. Let's yield a new print statement. Print expression. Is that true? Yes. New print expression. Identifier, open paren, expression, close paren. Let's create that. And this is going to be a very temporary expression. Come on. There we go. Then give me my constructor. There we go. Cool. And then we want that and that. We don't care about these. The span is from identifier to the close paren. Okay, so we have our print expression. And this is actually going to mean that we need a new type. Going to need a new type. Because when we type check this, we need two types. We need an any, because this is going to take an any. No, let's not go down that rabbit hole. But we need a void type, because this is not going to return anything, but it is an expression. So even though it doesn't return anything, the type of that return is void. So let's go to type checking. Expressions, and let's just put a to do. This is temp until we have proper functions and methods. If wondering the difference between a function and a method, I think they're the same thing, unless you're in a specific language that makes a distinction. My understanding is that functions are free floating, they're not attached to any type, and then methods are like class methods in Java, but I'm undecided what I'm going to be doing with classes in this language yet. What was I doing? I want a typed print statement. Typed print expression, in fact. Cool. The type. So we need a new type, and you know what? I kind of don't like that these are all spread out. So I think I'm going to yoink this, put it in there. Bull type. Aha, yes, because there's two of them. And then I don't actually need that, do I? Yeah. Okay. This is shat everything up. There we go. Can it be referenced from a static context? There we go. Now it can. Okay, so I do need that. Okay, you know what? I'm going to do that off camera. That's taking me down a bit of a rabbit hole. I want a void type. Or, you know, I'm leaning more towards this being like kind of a Rust-like Java. Because I like Rust and I like Java. So why don't we blend the two? So I might have a unit type, which extends a Jura type. What are you complaining about? You need to be final. And then you are going to have this terrible pattern as well. Like so. Cool. So the type of a typed print expression is... Instead of doing something like this, I wonder if the pattern could be like Jura type dot unit, and that just refers to this. It's kind of giving the superclass the knowledge of its children, but I mean it's a sealed type anyway. It has to have knowledge of its children. So here's what I'm thinking when I say I want this language to be like a Rust Java, is I want to have Rust-like enums, which are like discriminated, well, they are discriminated unions, where you can say, you know, I have a type or an enum Jura type, and then each value of the enum is a different type rather than a value. So I would have like a unit, and that doesn't have any parameters, but I would have another one which is array, and inside that it has a parameter which is the Jura type that it is the array of, and you get this kind of like recursive type. And in Rust, that causes some problems where you have to like start boxing the type because you get a sort of like a self-referential type, where Java doesn't give a shit because it's garbage collected. So I feel like you get like a nice flexible language with the like nice features of Rust. That's kind of where I'm heading towards with this language, but like we'll see how we go. So let's add this to the hierarchy. Let's make it final. And all we really have is an expression, and it's a typed expression. Like that. And then we want a getter. There we go. Cool. And then we need to type check. Where's my type checker? There it is. Boom, there we go. We have a compile error. Let's add the missing branch. With my font being so comically large, this is getting a little unwieldy. If you'll forgive me, just one moment. I'm gonna knock it down a notch. Yeah, I hope that's still readable. That's way nicer for me. I have it so large because I like, I did it originally where I was like coding at my normal size, and that was okay for watching it on a computer. But then I like watched one of my videos on my phone just to like see how it was, and trying to read the text on a phone was really hard. So I like to make it big so that you can see the text on a phone. If you're watching this on a phone, shout out to you. You're awesome. If you're watching this on a TV, I had some of the other videos for Do, like the stats for that. People were watching it on their TV, which is insane. Very cool. Anyway, let's implement this. So what we need to do is just basically get a expression, which is type checking the print expression's expression. How many times can you say expression in one sentence? And then we yield a new typed print expression with that checked expression. It doesn't like that because we already have expression, so let's call this nothing and just stick it in there, and then we can get rid of all of this. Very nice. See, this is the kind of shit, like, Java already supports this, so I can just make a nicer like interface to the whole sealed classes like feature in typed in discriminated unions, and it will just compile into whatever the hell the JVM is doing behind the scenes here, and then you get a nice like matching, pattern matching. Like they're leading towards pattern matching in Java, but they have all the baggage of how you know, switches work in since Java, like whatever the hell, like Java 1 probably. Whereas Jura isn't really tethered to that, and I can do whatever the hell I want. Anyway, this is a long way to implement a print expression. So, lowering doesn't affect expressions yet, so we don't need to worry about that. And then emitting should be an error somewhere. Yep. Because we need to know what to do with a print expression. And you know what we do with a print expression? This. We get the print stream, and we need this, and that simplifies this massively because we just emit the expression. And then we do this. So we visit, not like that, we emit with that the print expression's expression. Just call this the print expression. And we switch on the print expression's expression type. There is now a missing value, which is the unit type, which should really be a compiler error, because print as a function should have a type in its yeah, so this should not happen. And if I go into my type checker, when I type check the print expression, so I actually do need to do some checking. Wrap it with a block. We'll get that out, and we'll call this not print expression nor expression. Let's just call it expo. We just need to say if expo get type equals unit type. Yeah, this is awful. Throw new illegal state exception cannot print a unit. Something like that. So, if all of that has worked, this should now print nothing because it's if false. So this should now print true. Didn't even compile. Why not? Expected an identifier but got open paren. We already increased the cursor. Okay. Whatever. We'll do that. Local variable is whatever. Okay. It's annoying that I can't call it. Well, I can call it identifier if I want, but just like that. Now I can say if false, and I can give it an else, and I can say print, and I can put whatever I want in here. I can put 7 times 2. And it doesn't print anything. Because I don't lower else's. That is why. So let's lower else's, and then I think we can get on to whiles. Where's my lowerer? There he is. Okay. So I think we need... so if that we jump to end. For now, I'm just going to split this into 2 different branches, and then I'm going to see what's common between them, rather than trying to like keep half of this and then add the else in afterwards. I'm just going to say if statement get else body is not null, we'll do something. Otherwise, we do all of this. And we could probably make that common straight away. And then we can do that. So we need an end label and an if false label. We need to get the condition, or emit the condition. If it is false, we jump to if false. We emit the we need to lower the body, so we need to add all. The if statement else body, we need to lower that. Condition if false. No, we need to do the we need to do that, and then we need to do a unconditional jump. So this, yeah, this is a, oops, not that. a conditional jump. Yep. And then we have a unconditional jump statement, which doesn't have a jump op, it just has a label. So we'll yoink all of this, we'll remove the jump op, we'll remove that, remove this, remove that, and add it to the permits. Make this final. So, if it's 0, we jump to if false. So we need to add that label here. So this will jump to here, past the body. If we are true, we won't jump. We'll run the body, and then we'll do a unconditional jump to the end, and then we'll emit the end label after the else body. Okay, I think that makes sense, and I think it actually just makes sense to keep these separate. Yeah, I think it makes sense to keep those separate. You're not happy. Okay. I think you're just... yeah, you just needed a oh, that doesn't help. There we go. And then I think that the emitter is going to be sad now because there's a new type of expression, a new type of statement, which is the unconditional jump statement. And that just has a label, and then we just go to the label. Yeah. Have we seen the label before we do this? No. Ooh, but when we do while loops, this might not work. But for now, it's okay. And then we just visit a jump instruction, which is go to the label. Does that work? And compiled. There we go. So we can do else. And can we do else if? Compiles. Okay. Not bad. So, let's recap. Lowering. This I kind of don't like. I think maybe we should have the condition as part of the conditional jump. Like this Boolean. And then when we emit, we can decide what to do with that. Because if we look at the bytecode, well, for now that's so if I do like if 10 is less than 3 and run that, yeah, we end up with this kind of nonsense where instead of actually having the comparison, we compute the value and say is that less than 0, because the only jump instruction we do is if ec is equal. But it does work, it's just not the best. Cool. And because we now have the ability to do it from a file, let's make a while. So this will be, I remember now, we weren't going to do this until we have variables, but I think let's just have an infinite loop and we can just kill it. So while true, print 10. And I already added the while keyword to the syntax highlighting, but it is not in the language. So if I try to compile this, it's going to say, what the hell are you on about? I think it, I think it parsed this as a method call, and it expected there to be a semicolon. Yeah, I just realised I never actually check what we say here. It could be anything. It could be foo. And we just say, oh, that's a print. Wait. Yeah. Okay. That's stupid. Let's not do that. I didn't want to close it. My fat fingers. I wanted to open it. Print expression. Token. Case identifier. I think you can do guards in these. I could say something, identify X if X. Nah, it doesn't work like that. Say if token get text equals print. If it doesn't equal print, throw new illegal state exception. Methods other than print are not yet implemented. There we go. What are we doing? We've got the if. So this should work. And if I do foo, it fails because methods other than print are not yet implemented. Cool. Let's go back to the while. Methods other than print are not yet implemented because it thinks that this is a method call. So let's add the while keyword. God, this project is huge already. Right. While keyword. But I like how it's structured. I know Java gets shit about how many files you end up with, but I really like how it's structured. I mean, I think I can compress the types into something a bit more resembling a discriminated union. Maybe the same with the expressions. Like, this is kind of stupid. Like, I could just put all the expressions into one file, but then that file gets really huge. I don't know. Doesn't matter. All ends up the same bytecode in the end. Or does it? Who knows? I've been going for quite a while and I'm just rambling now. So that should now stop complaining about methods and should now complain about the while keyword. Let's parse a while statement. So here we have the if keyword. This is very similar to if, to be honest. It's going to be basically the exact same as this, just without an else. Unless we want to be really Python about it and allow you to do like a while else, and it will run the else on the final, or like, what is it? It like runs the else if the while loop never runs or something. Python while else is only executed after the while condition is evaluated to be false. Thus, if you break out of the loop or an exception is raised, the else is not executed. Niche. Very niche. Maybe we can do that. Because it's fun, and it's my language, and I can do what I want. This is a statement. So we'll do our regular song and dance about creating a new statement, and the span is from while key, because I don't have these there. So from the while keyword to the body, and then we have to have our getters, so get the body and the condition. Okay. So we've parsed it. So now our type checker is going to be very sad because we've got a brand new statement on the block. So it's basically the same as the if statement, except we don't have to worry about that. Like that. It's exactly the same. If the condition isn't a boolean, you throw. If it is, we return a typed while statement. Cool. So we give it one of them. And we do our regular dance. And then we need to give it a constructor. Do this stuff. If I wasn't doing this in IntelliJ, this would be really annoying. Cool. We have a new statement. So now our lowerer is going to be sad. So we go into our lowerer. And if we do this right, there won't be any need to implement any new lowered statements or to make any changes to our emitter. Because we have all of the pieces. We might need to make changes because I might have to change how we handle labels. But we shouldn't. If I'd have done that properly the first time, we wouldn't have had to make any changes. So we have a while statement. Let's get one of these and then yield them. So what do we need to do? Let's have a look at what if does without a body. And let's just copy its homework. So we create a new label end. We should have a different label which is the condition. And we need to emit that before the condition. Because we want to jump back here and evaluate the condition again. Because the condition could be some call to like some other variable and say, oh, is this true yet? Or, is this what is the value of this variable? We can't like cache this, otherwise it would stay false or true forever. So we need to do that. We need to emit the body, and then we need to have a unconditional jump. I don't know why I put so much source on that P. So we need to add a new jump statement to condition. And that's it. So I think that the bytecode emitter might complain. Could not find associated label. There we go. Because we emit the label before we jump to it. So I think in the bytecode emitter we need to have some sort of like get or create private label get or create label with a Jura label. Yeah. And do something like this. So we say if the labels contains the key Jura label get ID, return labels get Jura label get ID. Otherwise we create a new label, we put it in there, and we return the bytecode label. Now, there is a better way to do this, and it is fancier. We have like labels compute, and it gets real fancy. Get ID. So what was it? Like a by function. That's a remapping. That's a remapping function. That's not what I want. Get or default. What is it? Put if absent. Doesn't matter. There's a fancy way you can do it, but this is fine. Let's not put too much source on it. So we just need to get or create label with the Jura label. And the same for the jump statement here. Yeah, like that. And then for the label statement, same thing. And then we should no longer have that exception. But let's leave in that check and just say to do this shouldn't be possible, but I'm leaving it in case it happens? I want to know. It compiled, and we're printing 10s forever, baby. We have a while loop. We can never leave the while loop, or alternatively, we can never enter the while loop. But we have while loops. And now with this lowerer, like, you can see how powerful this lowerer is. Because if I now wanted to add for loops, you can break a for loop into a while loop. So like, if I had something like for int I equals 0, I less than 10, I plus plus in Java syntax, and I said, you know, print I, this can decompose into int I equals 0, while I less than 10, print I plus plus. So you take these parts, you take this one, you emit it first. You then take the condition and you make a while loop with that condition. You then, in the body, take the body of your for loop, and then you insert at the end of it this instruction. So if you turn your for loops into while loops, and then you have this list of instructions, you can then just feed that into the lowerer, and then it says, well, okay, I have a typed while statement branch, and it crunches it into lowered statements, and then you immediately just have for loops without having to touch your emitter. And then this can expand even more, right? Like, if I had something like for I in 0, 10, you know, some of the juicy, trendy syntax like this, I can just decompose this into something like this, which then decomposes into a while loop, which then decomposes into a list of lowered statements, which then comes out of my emitter already fully formed with bytecode. So you see why that kind of lowering step is really powerful. And then the simpler and the fewer instructions you have before you turn it into bytecode, the more optimizations you are able to do, because there's just less space to explore. You know, the search space of optimizations is just smaller. So, all that's to say is I think we've had a pretty productive session today. We implemented, I think, lowering. This has been a bit of a blur. I filmed the last episode and this one on the same day, just at different ends of the day. We implemented lowering, ifs, if-elses, print, while loops. I think the language is looking pretty healthy. Completely useless, but it's taking shape from its original state as just an expression evaluator, a fancy calculator. I think this is all very cool. So I think for next episode, I think I'm going to tidy up this, because this is a horrendous syntax. Not even syntax, this is a horrendous pattern. Like, every time I want to add a new primitive type, I have to make a whole class, I have to do this nonsense. Just because I want to be able to have custom types, which has a slightly more interesting pattern. Like, everything else should just be stuffed inside here. And then there should be like special ones for arrays and, you know, ranges and classes and maybe structs. You know, there's no reason this language can't have structs. Just because the JVM doesn't have structs means I can't have structs? No. I'm basically just making C#. Won't think about that. Yeah, so I think next time we'll probably implement variables. That's probably the next big thing, so we can actually do interesting things with our while statements. Once we have variables, we could probably do for loops, or whatever variant of for loops this language has. Because I quite like the more compact, like, for I in a range. They're not quite as expressive as regular for loops, so maybe there'll be the options for more. but I'm kind of a fan of like there being one way to do something, and it's like consistent across all of the like all of the examples you'd ever find. Like if this language, let's imagine for a moment this language was actually like widely used, and there was like 3 different ways to do for loops, then there'd be arguments for years about which is the best one to use. And it's just easier if you say, here's how you do for loops, have fun. And I think that's kind of like, I think that's like the philosophy of like Odin. I think it only has a for loop. It doesn't have a while loop. If you want to do a while loop, it's like for condition. And it's basically a while loop. Or something like that. I don't know. Yeah. I think variables, which means we need to decide on a variable declaration syntax and how we declare types. I think that's going to be a whole topic to itself. So I think that just, I'll leave it at that. We're going to do variables next. If you made it this far and you're enjoying Jura, please let me know. Leave me a comment, leave me a like, all the good stuff. Thank you very much for watching this far, and I will hopefully see you in the next one. Okay, bye-bye.